This will be our last lesson in the conic sections, and we're going to look at translating conic sections and what does that mean for us in writing the equation and in some cases sketching the graph. So let's get into some examples. Starting with problems 5 through 9, we took a look at examples of problems 1 through 4 in class already. So in problems 5 through 9, you're going to be asked to write the equation of a hyperbola, and they're going to give you information pertaining to the vertices and the foci. So what I've done here, you may not always have to do this, but I thought just to introduce how this works, I would just step you through a process. And you might find this helpful, and after you've done it a couple times, you can just kind of think your way through it following this procedure. All right, so the first thing I'm going to do, this is called the midpoint formula. I'm going to find the midpoint of the vertices that are given. So if you take the two x's and add them together divided by 2, obviously you're going to get x coordinate of 2 for the midpoint. If you add the two y's together, -1 plus 7 is 6, and 6 divided by 2 is 3. So the midpoint of the vertices, and for a hyperbola, that's also considered what we would think of for an ellipse as being the center. Okay, so again, these are hyperbolas that have been shifted from the origin. All right, so we found the midpoint of the vertices, which represents really the center of where the hyperbola is graphed. Now let's find the distance between the vertices, and that total distance is called 2a. All right, so distance, if you need to, you could use that distance formula. I'll go ahead and show it here. The distance formula looks like this. You do the x's subtracted from each other squared, and do the same thing for the y's. And then once you found that sum, you do the square root of that number. But a lot of times it's easy enough just to count spaces. We know that from 7 to -1, that's a total of 8. So 2a is equal to 8. So that means a would be half of that. And a is really the number that I'm looking for when I write the equation. So we'll kind of keep that in the back of our mind. We know what a is. We know what the center of the hyperbola is. Okay, now let's find out what c is, and I'm starting off with, just like I did with the vertices, what's the total distance between these two focal points? Well, from 10 to -14, that's a total of, or -4, sorry, that's a total of 14 units. Okay, so if you travel from 10 all the way to -4, you've traveled 14 spaces. 2c is 14, therefore c is equal to 7. And so now that you know what a is, which is 4, and what c is, we can go to our Pythagorean theorem formula and we can solve for b squared. All right, so c squared, 49, is equal to a squared, which is 16, plus b squared. And 49 minus 16, of course, is 33. So now we know what a squared is and we know what b squared is. And now we're ready to write the equation. So be careful. You need to pay attention to where the vertices and the foci are. And if you have to, you can just make yourself a little rough sketch. You don't have to graph these. But until you've done a few and you've gotten used to it, you might be interested in doing something like this. So there's 2, -1. And then I'm also going to plot 2, 7. Okay, I'm just going to call that 7. 2, -1, 2, 7. If those are vertices, vertices are the points through which my parabolas actually cross. So that means I must have two parabolas that open up and down. Okay, and the foci then would be inside those two parabolas. So what this tells me, since my two parabolas open up and down opposite from each other, that means in my equation y squared must be in the lead. All right, and we learned in class today that when I incorporate the center, okay, this is the x-coordinate, this is the y. Be careful here. I need to match up the y-coordinate with the y variable. So the first numerator is going to be y minus 3 squared. Okay, minus, and now I'll do the x-coordinate paired up with x minus 2 quantity squared. And remember, for hyperbolas, a squared is always the first denominator, b squared is always the second. And I'm done. That is my equation to represent that particular hyperbola. All right, let's try another example of one of these. This time we're told the vertices are at these 2 points, -1, 2, and 3, 2. And the focal points are provided. So the first thing, if you want to step through this, find that midpoint between the 2 vertices. So you would just add the 2 x's together and divide by 2. We can do that mentally. 3 plus -1 is 2. 2 divided by 2 is 1. And then do the same thing for the y's. 2 plus 2 is 2. 2 divided by 2 is 2. 2 plus 2 is 4. 2 divided by 2 is 2. So obviously the y-coordinate's not going to change. So there's the midpoint of the vertices, and now let's find the distance between those. All right, so obviously it's just the y-coordinate that I'm interested in, or I'm sorry, the x-coordinate that I'm interested in finding the distance. If I'm at 3 and I travel over to -1, I've traveled 4 places. Well, that's what 2a is equal to. So a, we can reason, is 2. All right, do the same thing with the focal points. You can probably tell that that's a total of 8 spaces away from this point to this one. So that's called 2c. So c is going to be half of that, of course. And now we solve for b squared. C squared is equal to a squared plus b squared. B squared then has to be 12. All right, so pay attention to where the vertices are. And once again, a little sketch may help. -1, 2 is here, and 3, 2 is here. This time our transverse axis is horizontal, which means we're going to have our parabolas opening to the left and to the right, which means x needs to be the lead variable. So I pair up the x-coordinate of the midpoint, or you could think of that as the center, with x minus 1 quantity squared, minus, and now to put in the y-coordinate with y minus 2 quantity squared, fill in a squared. A squared, of course, is 4. And we solve for b squared. We got 12 equals 1. So that is my equation. And that's what you're going to do on the set of problems 5 through 9. All right. So let's take a look at these problems where this starts with number 12, and you're only doing the evens. I've changed this assignment, so you're doing 12 through 22 and then 23. So I'll recap that in just a minute. 12 to 22 even, and then tack on number 23. All right, so this is called general form. We need to convert it into standard form. So this is where completing the square is going to come in handy. And there's several things we have to do. We have to, first of all, once we get it into standard form, identify which of the conic sections is being represented. Is it going to be a parabola, a circle, ellipse, or hyperbola? All right, we'll be able to tell, we should be able to tell once we get it into standard form. So to complete the square on x, I'm going to pull out this 4, this factor 4. Okay, notice that's equivalent. I just factored out 4. And then over here, I don't have to factor out a constant. I'll just leave that like it is for the time being. Okay, and now I'm going to actually complete the square. So in my quantity squared, I'm going to do x minus 3 Okay, and then over here, I'm going to complete the square on y, and that's y plus 3. Okay, so now you got to make sure you take care of this next step. On the left side of the equation, negative 3 squared is 9, and 9 times 4 is 36. So I'm out of balance at this point on the left side of the equation by plus 36. So to balance it out, I'm going to add 36 to the right. Over here, I'm out of balance by 3 squared, which is 9. So I'm going to add that 9 also. Okay, so going down to my next line, I have 4 times x minus 3 quantity squared plus y plus 3 squared, and that equals 36. Okay, so to make this to become either an ellipse, it looks like it's going to be an ellipse. It can't be a hyperbola because hyperbolas have minus here. And it can't be a circle because, as you can tell, when I divide by 36, I'm going to get different denominators, and that indicates that it's not the same distance all the way around from the center. So dividing by 36 gives me this: x minus 3 quantity squared over 9 plus y plus 3 quantity squared over 36 equals 1. Okay, so this is an ellipse equation. So the directions tell me for an ellipse, give the center. All right, so the center is going to be 3, negative 3. And we're supposed to give the focal points. All right, so we need to know what, that C stands for center, of course. We need to know what the distance is from the center to the focal points. And so we're going to use C squared is equal to a squared minus b squared for ellipses. All right, so c squared is a squared, which is 36, minus b squared, which is 9. C squared is 27. So I'm going to go ahead and have you just change these into decimal form. So let's just find the square root of 27 and round it. Square root of 27, and I'm going to call that 5.2. So it's 5.2 units from the center to each of the focal points. And now it's like this. From the center, am I going to travel this way to the focal points, up and down? In other words, is this a tall ellipse? Or am I going to travel this way, left and right, indicating it's a wide ellipse? Well, the way this equation is set up, a squared, which is the bigger denominator, is underneath y. So y is major, which means my ellipse is going to be the tall ellipse. So I'm going to go 5.2 units this way, and that will be one focal point. And then I'll go 5.2 this way, and that will be the other. All right, so essentially, I'm going to be adding 5.2 to negative 3 for this point, and I'll be subtracting 5.2 for this point. All right, so let's do negative 3 plus 5.2, and that gives me 2.2. So one of the focal points will be 3, 2.2. And the other one, if I move down this many places, it's like subtracting 5.2, and that'll be the point 3, negative 8.2. So my two focal points, foci, are here. Okay. And that's my final answer. I got the equation in standard form, I found the center, and I found the foci. Okay, so I'll just block this off. If you want to write it like this, that's okay. And here is my equation. Okay, let's do one more of those. Same idea, we need to change this general form into standard form. So this one needs to be organized a little bit first. I'm going to put my x terms together and then my y terms together. And my idea here is to complete the square. here I've got this 4 that has to be pulled out first. So I think I'm going to just take care of that. And then I'll complete the square on both variables on the same line. Okay, so just think factoring out -4, and that's going to give me y squared plus 8y, or I'm sorry, 2y. Okay, we're still equivalent. If I do -4 times y squared, that's -4y squared, and if I do -4 times 2y, that's -8y. And now we've set it up so that we can complete the square. So x minus 1 quantity squared, we'll be completing the square on x, minus 4, and then this is going to be y plus 1 quantity squared. And now let's take care of balancing out the equation. Here I have essentially added 1. -1 squared is +1, so that takes care of that. Be careful here because I did square 1 and then I multiply by -4. Notice that 1 times -4 is -4. So you could say add -4, but I'm just going to show it as subtracting. So typically we always add this number to balance it out, but in this case we would be adding a negative number since the 4 here is negative, of course. All right, so let's bring it down. 4 times y plus 1 quantity squared, and that equals 4. Okay, so once again, it can't be a circle. It is going to be a hyperbola. Let's divide by 4 all the way across. Minus y plus 1 quantity squared over 1 equals 1. All right, so our center is going to be 1, -1, 1 from the x variable, and -1 from the y. All right, and so to tell what the focal points are going to be, we have to understand how the two parabolas open. Since x is in the lead, then we're going to have two parabolas that open this way, left and right, from this center. 1, -1. So I'm just going to call this 1, -1. And so my focal points are going to be, I'm going to travel to the left and to the right, c units. And so I have to find out what c is. C squared is equal to a squared plus b squared. And b is 1, b squared is 1. C squared is 5, so c is the square root of 5. Just a little bit more than 2. Yeah, we'll just call it 2.2. And I'll go ahead and say plus minus 2.2. So from the center, I'm going to travel left 2.2, which is another way of saying 1, +1, the x-coordinate, minus 2.2. So let's just do that. 1 minus 2.2 is -1.2. I'll just put them here. One focal point will be 1, -1.2, -1. And from this center, I'm going to travel to the right 2.2. So that's like taking my x-coordinate, since I'm traveling to the right, take the x-coordinate and add 2.2 to it, and you get 3.2, -1. All right, so this would be that -1.2, for example, and this could be the +3.2, and they're all on y is -1. Okay, so I hope that helps you out. These are a little bit more involved because you had to do that completing the square technique. We will take a look at these tomorrow. Let me know if you have any questions.